So, so before we jump onto like anything advanced in data engineering, like designing the data pipelines or developing the data pipelines, or writing the code or logic for transformations or business logic, or even even before like doing any kind of data modeling, or or even before building like any kind of machine learning models or anything. So we unfortunately like always forget to kind of ask one most important but simple question. Okay, and that question is basically that question is basically, where does the data even come from? Okay, so let's write down that question. Where does the data even come from? So most of us, what we kind of do is, whenever we get some kind of requirements from business people, we directly jump onto writing the code, and we are so in a hurry to develop that Python code or PySpark code or SQL code, and most often we ignore where the actually data comes from. Even though we work with the data in day-to-day life, we most of the time unfortunately don't realize where the data actually come from. And even if we do realize where the data actually comes from, we don't realize the nature of the nature of the place, or the characteristics of the place where it comes from. Okay, so let's talk a little bit more about it. So whenever we ask this question, where does the data come from? Many people, what they say is, so it is like really easy, Harsha. What are you asking? They will just say it comes from so and so so system X or so system Y, or some people will even go one step further and say, it comes from transactional database, or it comes in files, or it comes as part of API or something like that. But some people won't even be able to like answer that question. I've seen some kind of junior engineers, and even honestly, like to be honest, even some mid-level folks as well. you know um, um, People don't really spend effort and time in understanding the actually in understanding the data and where it comes from, and people start designing and building the data pipelines right away. Okay, without understanding the system that's basically generating the data. And and then um, and basically what happens, when you don't understand the source. Okay, so why do we need to care? Like, you can ask me, you can question me, you can argue that why do we even need to like care about where the data comes from, right? So if you don't actually, most of the times, I have observed that if you don't understand where the data comes from, we kind of tend to develop the code in not so good way. Okay, and most of the time it won't end up working, or even if it is working, it won't end up covering all the different edge cases and scenarios. So most often what happens is, the data pipelines break production, and then also sometimes, like, not sometimes, most times I would say. Okay, and also dashboards normally can show wrong numbers. Okay, and then of course, even if you have like some kind of machine learning models, they might behave like super strangely. Okay, and then that's not good, right? And then if let's say if these kind of things happen in production, then everyone will be pointing the fingers at you, because at the end of the day, we talked about it like so many times. Okay, at the end of the day, what's the objective of data engineering? It's to basically convert raw data to useful data, right? So it's basically to convert raw data to useful data, and useful to the business people who are in a position to like who are in a position and who are capable of making the business decisions, that will improve the company's revenue by optimizing the products and processes, right? So, and then if the pipelines are breaking, or if the dashboards are showing wrong numbers or wrong analytics, or if the machine learning models are behaving strangely and not able to kind of give out like proper predictions, then it's actually it's not it's not helping out, right? So if all these things are happening, then this is basically in dilemma. Okay, then we won't be able to easily make useful data that can be used by like business people. So we don't want to end up in that kind of situations. So that's why we should spend time and energy into understanding where does the data even come from, and what's the nature and characteristics of that data. Okay, so okay, let me put it that way. Okay, so today's video is mainly about, okay, source systems. So we all of course know that data comes from source systems, but then my point is that most people don't spend like time and effort in understanding the nature and characteristics of source systems. Okay, and for some of you, if you don't know what a source system is basically, source system is just simply a place where the data is created or generated before it reaches you. Okay, source system is just a place where the data is created or generated before it reaches you. Okay, and that is just the source system. And then one more important thing we need to be aware of source systems is, most of the time, or not most of the time, actually I would say always. Okay, um, any data teams or data engineers, right? Data engineers, they won't be owning the source systems. Okay, they won't be owning the source systems. Okay, so we are not in control of it. Okay, what do I mean by like we are not in control of it? When I say we are not in control of the source systems, I mean that we don't have any control over its structure or design, or basically how it behaves. Okay, we don't have control over the behavior, we don't have control over the design of the source system, and then we also don't have control over the behavior of the source system. Okay, it's the these all things will be naturally controlled by business, and of course like people who are responsible for maintaining that source system. Okay, and then unfortunately one more important thing we need to keep in mind is, even if it is like really even if it is like really inconvenient, okay, to work with some certain source system, even if it is inconvenient, you can't do anything about it, you can't redesign it, you should work with it as it is. Okay, so that is also one more important point we need to keep in mind. Okay, even if it is inconvenient, we can't do anything, and then we need to work with it as it is. Okay, so this is what we need to keep in mind. Okay, and then if you are wondering, like for example, like if you are wondering uh, like what is like, can you give examples of, if you ask me like can you give examples of source system basically can be anything. Okay, for example, source system can be like a banking system. Okay, it can be banking system which is processing the transactions. Okay, or it can even be like a e-commerce shop, e-commerce site, which is for example processing orders or storing orders information. Okay, or for example, it can even be like in tech terms, it can even be like a message queue streaming the real-time events. D- don't um, it's completely fine if you don't know, like if you don't understand what a message queue is. We'll of course talk about it in the coming videos. Okay, you know. But here it's a we are saying that a source system can also be like a message queue which is processing, or which can be processing some real time events, or which is streaming some real time events or something like that. Basically it can be anything, guys. Okay, it can be anything, which is generating some data basically. So that is the source system, right? And then and then depending on the source system, depending on the type of the source system, and depending on the nature of the source system, so the data in the source system like can behave like differently. Okay, when I say data in the source system can behave differently, what I basically mean by that is, okay, what I mean by behaving differently is, so one in terms of volume, one more in terms of velocity, or one more in terms of like consistency. Okay, and even reliability. Okay, for example, if we talk about volume, some of the source systems can be generating only few transactions per day, some can be generating like tens of transactions, some can be generating thousands of transactions, and some can be generating like millions of transactions. Okay, depending on the depending on the scale and type of the type and nature of the source system. Okay, and then if we talk about velocity, okay, velocity is basically the speed at which it is generating the data. Okay, so what do I mean by like speed at which it is generating the data is, some of the source systems can be generating like only few tens or thousands of transactions in entire day, but some of the source systems can be generating maybe like millions of transactions per in few minutes as well. Okay, so that can happen, especially in this digital age. Trust me, guys, that is like super common. Okay, and then in some source systems, consistency, data consistency also can vary. Okay, and of course reliability completely depending on the source system, and then how it is designed for reliability, and the technology behind it also matters. So this is actually a little bit about source systems. And then if we talk more, um, some of the are two of the most common source system patterns that you get to see nowadays, not just nowadays, from long time is, okay, let's talk about them. So one is application server and database pattern. So this is pattern one. Okay, and then one more pattern is IoT swarms, or event driven or real time. Okay, event driven or real time source systems, real time streaming source systems. Okay, so these are actually two of the most common patterns that you get to see in real world. So don't worry if you don't understand like what are these patterns actually means, and how they look in real life, and how we consume the data from them. So we are going to talk about all of that stuff in a minute. Okay, so let's talk about the first one, which is application server and database. So let's say for example, imagine like you are working from home, and then you got hungry, but then you have a lot of work, and then you can't prepare your food. Then what you normally do? Okay, if you are staying in India, then we have like basically Zomato or Swiggy, or maybe Jepto, or something, right? So what we'll do normally, whoever offers like give some coupon or something, we'll go to that that food delivery app, and what we do, we basically in first pattern I'm talking. So we basically open the app, and then what we do is we search for the restaurant, And then once we find the restaurant, what we'll do is we'll go through the items, or basically we'll go through whatever the food items that are present in the restaurant or the menu, and then we'll add the items into the cart, whatever the items that we like, and then at the end what we do is we will check out, right? So in this case, let's say if it is like application server and database pattern, how it will work in the background, or behind the scenes is basically there will be something called application server. What this application server will do is it will process each and every single step. Okay, it will process each and every single step, in the sense like whenever you do some kind of operation in the front end, or whenever you click something, or whenever you take some kind of action, what it will do is it will execute, or it will call the business logic related to that particular module. So for example, this application server process every single step in this flow, which looks like, for example, one of the step can be, okay, it processes or it calls the code related to user logging in, okay, or basically items adding to the cart, okay, or some other step can be like basically, let's say, payment started. Okay, so what it will do is basically it will redirect, whenever you click on place order, it will redirect, or it will call the code which will basically call the payment gateway. Okay, and then of course payment started, and then closed, and then after that place order. So what this application server do is, so it will basically process, uh, or it will basically execute all the business logic related to each and every step whenever you click something in the UI. Okay, and then so if you still don't understand it, you can think of application server like a like, let's say you go to the restaurant, what you will do is there will be some waiter, right, who will take your order or request, and then he will process it. So in the same way, okay, this application server is also exactly like that. Okay, so whenever you go to an application and then try to do something, it will take all the requests, and then it will route the requests to the corresponding modules, and then it will process them. But then one thing you need to understand about this application server is, this application server by itself, it won't store any data. Okay, in the sense like not in a fully way, I'm not talking about like in memory cache and all that stuff. Okay, mainly, but it won't store like any kind of like huge data and all. Okay, there will be some respective database which will be storing the data. Okay, so what this for example, what this database will be storing here is, for example, since here you are trying to order something from the restaurant, right? So it will be, for example, storing about the order details, whatever you ordered, your order ID, and the items you ordered, and then from where you ordered, like which restaurant, for example, and then what is the location of the restaurant, and who's the owner, okay, and all the details. And then of course it will also store your address, okay, and then some kind of timestamps, like what time you have placed the order, and then all that details. And then of course also your payment status. Okay, whatever. So what basically it will store all the details that are required to complete the transaction. Okay, or not just to complete the transaction, it will store all details that are kind of related to the transaction. Okay, so now what will happen is, and one more important thing I will say here. So here we are calling this thing as database, right? So this is the database that people normally call operational database. Here I am introducing one new term. So this is actually really important. Okay, so this is the one you will normally get to hear when you are working closely in the data world. For example, you might have heard about the terms like OLTP and OLAP, right? Online transactional processing and online analytical processing. So the OLTP that we talk about, this is kind of the OLTP, operational database. That is the OLTP that we normally talk about. Okay. So even if you would have gave like some kind of interviews for data engineering or any kind of data roles, you would have probably got this question in as part of the interview, like what is OLTP, what are the differences between OLTP versus OLAP, right? And this is the actual OLTP, that is the operational database. Okay. And why we call it operational database is it is basically supporting your applications operations, right? And then it is basically supporting your company's operations, right? So that's why it's called operational database. So I hope it makes sense. So that is the that is one of the important word like that you need to keep in mind always. And then okay, Harsha, you wanted to talk about source systems as a data engineer. What will I do like by knowing all this stuff, right? That might still be your question. So what you will do is, so what normally happens is, let's say we talk in the previous video, we talked about like how normally a data platform or a data team will get formed. So one of the scenario is, let's say there will be some business people who will realize that they want to make some kind of decision making, but they don't want to make the decision based on the gut feeling. They want to make the decision based on the data, right? And then that data, obviously you don't have data platform, but then there will be your company's data will be getting stored in some place, right? Hopefully. Okay. So it will be getting stored in some place, right? And then you have to get the data into your data platform. If you don't have data platform, you kind of have to make a data platform. And then what you need to do is you need to go to the database or basically the operational database in this case where your data is getting stored, and then you need to connect to it. Some cases there will be like pull and push patterns, pull and pull and push patterns that we are going to talk about in later videos. But you kind of need to connect to the operational system, fetch the data, and then put it into some storage. And of course you might do some transformation, or you might do transformation after storing it into storage. So storage, and then maybe after doing transformation you might store it again. So I'm not going to get into like ETL and ELT discussion in this video. Okay. We'll talk about it in the later videos. But then if you want to if you want to build a data platform, and then if you want to go through all the data engineering life cycle that we talked about in the previous videos, you obviously have to like pull the data from somewhere, right? And this is the place you are going to pull that data from. That is the operational data store. So now, so whatever for your analytics, okay, or reporting, or machine learning models, whatever it is, okay, whatever your use cases are, okay. So whatever your use cases are, any kind of, or it can be even be like dashboards as well, okay. So for your analytics jobs, or if you want to build some kind of analytics, or if you want to do some reporting or machine learning models or dashboards, normally you have to get the data from, not from actually application server itself, okay. You will have to get the data from operational database, okay. That you need to keep in mind, okay, because this is our source of truth, okay. And this is actually one of the most common source system patterns that you get to see in like companies. So this is like this is, I think, I would say like in most places I have been in, this is the pattern they were following, okay. And then there will be other pattern, okay. The second type of pattern is, this is the second type of pattern, right? We talked about like IoT or event driven source systems. Okay, let's talk about them. Let's talk about the let's talk about the let's talk about IoT or event driven source systems. Okay. So yeah, these are actually little bit, I would say these are actually a little bit challenging to, work with. At least in my experience, any kind of event driven system is like, yeah, like little bit like, like crazy girlfriend. Yeah, they are like a little bit difficult to handle. So now imagine. So in previous case, okay, this operational data store or database, it is mainly structured data, right? Here most of the cases you will get to see only the structured data, okay. um, but in this case, you really can't say whether it is structured or unstructured, or whether the schema changes or whether the schema will be same for the data. You really can't say that. But in this case, normally what will happen is, like there will be like thousands or millions of tiny devices, okay. So what that devices will do, they will be sending you some kind of data points each and every few seconds, okay, or each and every second as well, okay. For example, if we have to see the examples for this one, if we want to understand the examples for this one, some examples for this would be like, some, let's say, smartwatches. Okay, smartwatches are the like best example. So smartwatches, what they will do is, they will read, for example, every smartwatch will have some kind of sensors, right? What they will do is that sensors will read your or capture your heart rate or pulse rate and breath rate and sleep cycles and all that stuff, and then they will be sending all that data, okay, as soon as they capture, to some kind of normally message queues. Oh, sorry, spelling mistake. Okay, so they will be sending the data, okay, like every second. We are not talking about like every minute or every hour or every half a day or every day or every month. We are talking about like literally second latency, okay. Every second they will be sending some kind of data to some place, and that will normally be in many cases it will normally be like message queues. And then if you want to see like more examples for this, for let's say in some places like malls or some offices, there will be normally door sensors, right? So door sensors, what they normally do is they will detect the motion as soon as someone enter the building or someone enter the room, and then they will send that data to some whoever want to consume it, or to basically some message queues also. And then even if you want to see more examples, like let's say if there is some factory with a lot of machines in it, okay, and then those machines also might send a temperature and a temperature or or vibration metrics of the machines, okay. How many times like a particular machine is vibrating, or a particular component is vibrating in a machine, that kind of metrics, or are also basically temperature of the machine, okay, the temperature readings. So all that kind of data also they will be sending, okay. So this is basically IoT or event driven source systems. As soon as some event happens, and then you will be pushing that data to somewhere, okay. And even best example also would be like let's say maybe some Tesla car or some modern fancy cars, okay. What they normally do is they will send like speed and GPS location and all that data, okay. GPS data and all that data they will be sending to some message queues, right? So this is also nowadays actually in this modern digital era, these systems also you get to see like lot often, okay. But I would say compared to the first pattern, which is application server and database pattern, the other pattern IoT or event driven systems pattern is little bit uncommon, okay. So in most of the cases, most of the scenarios, you'll get to actually like experience or work on application server and database pattern. But trust me guys, nowadays even driven source systems are increasing like crazily. Okay, so let's say if you have to if you have to like draw it in a simple way, let's say in application server pattern, what will normally happen is you'll have app server, let's say 1, and then you'll have app server 2, and then app server 3. Okay, um, so which are application servers basically, and then what will be there is here there will be some kind of database. Okay, so some kind of database which will be obviously I won't put it like this, so which will be like storing all the data. Okay, and of course like from the application itself, even when you go into the application, let's say you go into the food delivery app that you ordered food from like some time back, even if you go into the same application and if you click on order history, what will normally happen is this application server will make a call to the some part of the code, and then that code will query the data from this operational database, and then it will get the results, and then it will send it back to the application server, and then that will display it in the user interface, and then you will get to see it. So normally that is what happens. And then what we are saying is so there will be some data platform, okay, somewhere here. Okay, so there will be some data platform here, okay, which will be following data engineering lifecycle hopefully. And what they will do is normally they will read the data from, okay, application server. Okay, they will read that data. Okay, or application server will basically push that data, and then that data platform will take that data and then put it into their storage. So and then if you have to sketch IoT or event driven systems as well, right? So they will look something like this. For example, in this case, you'll have a lot of you'll have a message, you'll have let's say we talked about tiny devices, right? There will be a lot of tiny devices which will be sending the messages. So there will be some device here. Okay, let's say this is the message. So yeah, so let's say this is message queue. Okay, so it's like this. Okay, there will be device here which will be sending the message to this. There will be device here which will be sending the message. So there will be like so many millions of devices. Okay, for example, we are talking like, let's say we are talking about smartwatches as a device. Okay, then imagine how many smartwatches will be there in the world, and then how much data they will be capturing like every second or every minute, and how much data they will be transferring it to the message queues. Okay, so so it's really important to understand this distinction. Okay, and then in event driven source systems, normally one more important point, like most important point that you need to understand is these event driven source systems, what they normally do is they just emit the data. Okay, they just push the data. They just not even push, like push is not the right word, I would say. They just emit. Okay, they just create the data, capture the data, and then emit it. Okay, and then they will be emitting emitting the data like 100 100 events or 1,000 events, or or even in millions per minute depending on the scale. Okay, and then and then uh, um, and then normally these messages normally should go somewhere, right? We are talking about like these messages should go somewhere, in the sense we are talking about like this place, right? Obviously, so these messages should go somewhere, in the sense. So this is normally, for example, like a message queue or a or like a streaming platform. Okay, So when we talk about streaming platform, that will be like Kafka. You might have for sure heard about like Kafka, right? So Kafka, or Kinesis in AWS, or MQTT, or any kind of publishing, subscribing stuff. Okay, platform. So, and one more most important point you need to understand is you need to understand between the two most common patterns is in pattern one, which is application server and database pattern. Okay, what you are doing is you are connecting to the operational data source, operational database, or operational database or data store, which is normally your source of truth, and then you are fetching the data. Okay, or they are pushing the data towards you. But in this case, you don't have direct interaction with the source system. I mean, you do have some kind of interaction, but here how do you see what do you see, what do you consider your source system as? Do you consider watches as your source system, or do you consider this streaming platforms, or message queue as source system? Okay, so in this case what you need to understand is, so these tiny devices, they are just emitting the data. Okay, it's not like you are pulling the data from them, they are emitting the data, and then you will be kind of listening to some message queue or streaming platform which is subscribing. Okay, and then you will get that message as a, you will get that data, and then you have to kind of process it. Okay, and here one more most common or most important point you need to remember is, this is like really important point. So most of the streaming, whenever I worked on like any event driven architectures or streaming platforms, okay, so there will be like normally a buffer of how much time the data can be present in the message queue, or or in the streaming platform, and then once that time has been passed away, then that data is gone forever. Okay, you need to like literally remember this. Yeah, so that is again one of the most important point, guys. Okay, so now now it all comes down to this most important question again. Okay, now so how do you, so basically okay, this all is fine, but then now the most important question is, how do we actually evaluate a system, evaluate a source system, like before building anything? Okay, how do we evaluate a source system before building anything, or before developing some kind of ingestion logic or transformation logic, or before doing some kind of data modeling, or before making machine learning models as well? Okay, so how do we evaluate a source system before building or before doing anything? Okay, what is the criteria, or what are the key considerations, if I put it that way? What are the key considerations, or what are the key things that you need to consider, or that you need to understand about the source system, in order to build your ingestion logic, or your transformation logic, or your business logic basically? So that will be, you need to first things first. Okay, it all comes down to this video. Most important part of this video is one thing is the patterns that we just talked about, and the other thing is the key considerations that we are going to talk about now. Okay, first things first, you need to understand what kind of source system it is. Okay, so you need to understand kind of source system. Now you might get the doubt, okay, what do I mean by when I say kind of, you need to understand kind of source system, what do I mean by that? So I'm saying that you need to understand, for example, is it is it application, is it a application database, or a streaming device, or is it an API? So you need to understand that. So you need to understand whether it is application database or API exposing the data, or you need to understand if it is a streaming device, like scanners or watch sensors or IoT devices or stuff like that. And then one more most important thing, you need to always keep in mind is before, because you need to keep that in mind is, um, um, it's really important to, it's really always important to know, okay, um, from what kind of source system you are, pulling the data from, like whether you are pulling from a, banking database that kind of updates like 1,000 times or millions of times in a day, or whether you are pulling from, like, let's say some kind of university attendance system that updates maybe once a day. Okay, so you need to really understand what kind of source system it is, and then you need to understand how the data is stored in source system. Okay, how the data is stored in source system. So what do I mean by, again, how the data is stored in source system? I mean that, so whether if the data is stored permanently in the source system, or whether it is stored temporarily, like in case of like event driven architecture or streaming devices and streaming architectures, like we talked about, there will be some kind of buffer, right? And then once that buffer timing is gone, then your data is lost forever. Even like, let's say in case of application logs or some kind of web server logs, um, typically, like, you'll normally maintain that kind of logs for a day or a few days, and then once that is done, then it's gone. Okay, I mean, in reality, it's not like gone forever. In some cases, there will be some kind of archival mechanism in place. Okay, but then in some kind of streaming services, it's literally gone. Gone means gone. Okay, um, so you need to understand that. Okay, you need to understand how the data is stored, whether it is stored permanently, or it is getting overwritten. Okay, or it is getting overwritten, or maintaining only latest data, or it is getting deleted quickly. So you need to know that. Okay, and then one more important point that we also a little bit touched upon already. You also need to know the velocity at which data is getting generated. So basically, how fast is your data getting generated? Okay, how fast is your data getting generated? So whether it is like some tens or thousands of records in entire day, or whether it is some thousands or millions of records or transactions in a second or in a minute. So you need to understand that. And then you need to, of course, the most, everything is important, but this is also the most important, that is how clean, okay, how clean or consistent the data in your source system. Okay, how clean or consistent the data in your source system. When I say this, like, what do I mean by clean or consistent? In the sense, do you have like some of the source systems I worked with, they normally have like missing values, the most common, and then of course free text fields. Okay, free text field in the sense there will be some text field, and then you can put in basically anything into that field. Okay, now as a data engineer, it's a little bit challenge for us to process that kind of information, right? Like, so let's say I can write whole sentence, but then some other people can put in their put in their personal details, and then some other people can put in blah 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 or something else. And then, for example, how do you process that? If someone is, even though you advise them not to put their personal details, if they are putting, but then you need to have a strategy to handle that. How do you do it? Okay, otherwise you are not compliant basically. So you need to know that. Okay, so you need to know whether if the source system has missing values of free text fields, or sometimes they might have different time zones. Different time zones in the sense, um, of course, like some people will be following like some kind of standard time zones, but some people, I literally saw in many systems that people have different values from different time zones, okay, and some people will store you know date in some columns, okay, but timestamps in some columns, okay, or date values as strings, okay, or maybe let's say in age column, if there is a age column, there might be some values like 9999 and maybe 10,000. So now if it is not like sadhus or something, if no one attends spiritual powers or anything, like no one can live in these many years, right? Now what does it mean? So you need to know like how clean or consistent the data in your source system, okay, and then of course you also need to know if you expect any kind of errors in the source system. When I say errors, it can even be like duplicates or something, okay, and then or maybe some kind of let's say instead of dot there might be some comma in the amount column. Then what will happen, that will create a lot of issue with the data quality. And then if you are doing some kind of thing like invoicing or something like that, then the comma or dot, it can create like huge difference in the total amount, and then even companies can get like crazy losses. We don't want that to happen, right? So obviously, so you need to know what kind of errors or duplicates you get, and how clean or consistent your source system is, and velocity and all that stuff. And then you also need to know um, uh, if you also need to know, do events arrive late? What do I mean by do events? Events in the sense like I mean data here, okay? So do data arrive lately? Okay, do data arrive lately is like, let's say you have a device which normally whenever it is connected to internet, and then whenever it is connected to internet, what it might be doing is the sensors in the device might be reading the data, and then they will be sending or transferring the data on a network, to some kind of place, maybe some message queue or streaming platform, right? But then, think of this scenario. Now, what happens, when it is not connected to internet? Okay, so when it is not connected to internet, the device or the sensors might still read the data, um, but then they won't actually send it. Okay, they might still be syncing the data. They might not actually send it. Okay, they will send it as soon as you turn on the internet on that device. Okay, so now here if you see, the actual time of events or data creation is different, and when they are arriving to message queue is different, right? So here basically we are saying transaction timestamp is different, okay. Transaction timestamp is different than data arrival timestamp, okay. So you need to always keep that in mind. And and then uh, and then the most common issue, guys, okay, the most common issue is schema drift, okay. So I think probably like unless you are a junior or some mid-level engineer, if you are like senior engineer, then you probably would have heard about it like probably like 1,000 times. Schema drift is whenever schema changes in the upstream, basically, which is in the source system. Schema changes means, what do I mean by schema changes? For example, new field, okay, new field might have been added, or some field might have been removed, or data type change, okay, data type change, someone changed the data type from integer to decimal, or string to varchar, or something like that, or even even in the ordering of fields, okay. Let's say one of the field is in column index 1, but then it changed to different index, then that also might cause issues. So you need to know that. So, and actually most of the time, as per my experience, no one, a funny thing is, no one actually tells you whenever schema changes, even though people normally now creates data contracts and everything, and then actually upstream, whenever they make some schema changes, they are supposed to inform you, but then due to whatever reasons, it can be bad governance, or it can be bad communication, or it can be like of various reasons. Most of the time people don't inform, and then you will only find out whenever you are, whatever the pipeline you are running overnight, whenever it fails, and then morning whenever you open your monitoring tool or whatever, and then you will see a lot of red color, and then you'll be like, why is it failing so much? Okay. And then if you see the logs, then you will find out that, oh, schema is changed, or some fields are removed, or the data type of the fields have been changed. So this is also one of the thing that you need to aware of, like how often schema drift happens, like how often like schema changes in the source system. Okay, you need to know that. And then most another most important thing you need to know is, can reading the data from the source system, can reading the data slow down the source system? Okay. Yes, it can. Okay. So yes, this is again one of the most common case again. So in production systems, okay, especially in this case, where you have application server and database, operational database, so it can slow down the source system. So whenever source system is operational data store, and then let's say if you have like some kind of heavy queries that you are firing towards the operational database, especially during work hours, okay, then there might be load on concurrency and everything, like from the from the front side, from the operations perspective, and then there might be also there might be also load from your side, from the applications, from the data platform side as well. So if you are finding such kind of heavy queries, okay, on the operational data store or operational database, then it can actually slow down the source system, especially during work hours. And thing is, what we want to do is, you need to kind of try to avoid contention. Okay, again, there you go. I'm introducing one more new word again. Yeah. So what we need to do is, we need to avoid something called contention. So now what is contention? Contention is basically, fighting for resources for executing the queries. Okay. So whenever during the work hours, users will be obviously, they want to do something on the application, but then at the same time, if you are from the data platform fighting your heavy queries towards the operational data store, then it might be, in contention with the user queries, and then if user queries get delayed, and obviously they will lose in interest, and some in worst cases it can even lock the tables, and then users might lose the interest, okay, and they might switch to different applications, and we don't want that to happen. Okay. So you should obviously know whether you should understand this thing as well, whether reading the data from the source system during some particular hours, or during especially work hours, can slow down the source system. Okay. So you need to know that. So these are actually some of the important points. Okay. Let's summarize what we discussed today. So today our main objective of this video was to like understand before writing any kind of before writing or developing any kind of ingestion logic or transformation logic or any kind of data modeling or machine learning models. So we want to understand, since we work with data, always we want to understand where does the data actually come from, or even come from. And then if you don't understand the and then we found out that the answer to that is source systems, and then source systems is the place where data is normally created or generated, and it can be like banking system, or e-commerce storing the orders information, or it can be message queue streaming the real-time events, right? So if you don't understand the nature of the source systems, what might happen? Our pipelines might break, data dashboards can show wrong numbers, or machine learning models can behave strangely as well. And we don't want this to happen, because at the end of the day, as as the objective of data engineering is to convert raw data to useful data, useful to business people. And if it is not, if the data we are providing is not useful to business people, then there is no point, right? So obviously we don't want that to happen, and we want to understand all about our source systems. And then we talked about the two most important patterns of source systems that we get to see in from in organizations. One is application server and operational database pattern, and then other pattern is IoT swarms and event driven real time streaming pattern. Okay, so and then we talked a little bit about application server and database operational database pattern. And then we talked of course also about IoT and event driven source systems. And then we talked about examples for them. And then and then the and then we talked about the main final most important question of this video, that is, how do we evaluate a source system before building anything? Okay, so what are the key considerations for that? And then we summarized that we need to kind of understand before writing any kind of code, or before developing anything, we need to understand these following things about source system. That is, we need to understand the kind of source system, that is whether it is application database or API or streaming device. And we need to understand also how the data is stored, whether it is stored permanently, whether it is overwritten, whether it is deleted, because this also, guys, can help you design something called as idempotent. Okay, idempotency in data pipelines. Okay, but that's for different video. Okay, don't worry. um, and then we also need to understand the velocity, okay, at which source data is getting generated, source system is generating the data. And then we need to understand the cleanliness and or consistency of the source system. Okay, and then we need to understand whether the source systems can produce any errors or duplicates or any as such, so that we can while writing the code or while developing our logic, we can address for these issues accordingly. And then we also need to understand, do events arrive late? Okay, if they do arrive late, then we need to obviously make a logic that will handle the late arriving events. Okay, yeah. And then we need to understand how often the source schema changes in the source system. Okay, that is schema drift. And then we also need to finally understand, can reading this data from the source system slow down the source system? And we kind of concluded that in most cases it does. Okay, so you kind of need to align on the schedule and all the best practices with the architects and the relevant developers to ensure that this won't happen, especially. Okay, so that is the main point of this video. So I basically wanted to mention that it's really important to, I agree that as a developer, I literally agree that it's really important to develop or write neat code and best business logic, effective and optimized and performant and reliable business logic. Okay, that performs well. But at the same time, in my experience, I kind of understood that how much of a good code you write, sometimes there will be, you might have heard this probably like so many times. Okay, how much ever the good code you write so many times, sometimes there might be some scenarios or some edge cases which won't be in your control, right? So I used to think, okay, are you sure, like is it really true that we are not in control of everything? Yeah, probably we can't control anything, everything. I agree, but at the same time, this scenario is not one of those. Okay, so most of the time, our edge cases often come from not analyzing and understanding the nature and characteristics of our source systems properly. Okay, so we need to properly understand our source systems, and then trust me, guys. Okay, it will help you a lot. Okay, and if you match this with proper coding, proper best practices with the coding, and if you bring out the best from both worlds, if you bring out the best business understanding, if you understand in the requirements of customer, and if you understand what kind of data you have in source systems and the nature of the source system, and then if you have good programming skill, then you will be like top notch engineer, I would say. Okay, and and if there is like one message I want you to like take away from this video, I would say that data engineering does not start with writing or developing any kind of transformation logic or ingestion logic. It starts with understanding the business and source. Okay, period. um, Okay, and you might also probably think like, Harsha seems like a crazy, super knowledgeable and intelligent guy. Trust me, guys, I'm not at all like the smart guy. There are like so many smart people out there who are smarter than me. But there are some things like I learned in my career through, I would call battle scars. So I made like so many huge mistakes, and then I wanted to fix them, and that's why I went on exploring the answers, and I found also this as one of the answer, and then I wanted to convey the same to the community, to you as well, because I really believe in shared learning and knowledge sharing as well, and yeah, so that's nice. And then if you feel like this video helped you in some way, like in understanding the source systems in in more clearer way, please like, share and subscribe. That will be really nice. And then um, and then of course I'll come back to you again with one more interesting topic in the next video, and until then, stay tuned, and see you, and yeah, talk to you again. Bye.